NXP Solutions, NFC Essentials. Near-field communication is a short-range wireless connectivity technology which allows us to interact seamlessly with the world around us by just tapping our device in front of another NFC-enabled device or an NFC tag. It is designed for intuitive, secure, and simple communication. NFC builds upon the standards of RFID. This technology is based on the principles of electromagnetism. It uses radio waves to exchange data between an RFID reader, also known as transceiver or active device, and an RFID tag, also known as transponder or passive device. Within RFID, we can work at different frequencies from the low to the ultra-high frequency band. RFID is standardized in the ISO 18000. Contactless proximity technology is a subset of RFID that works at 13.56 MHz, using the same communication principles as the RFID technology. It has an operating range of up to a few centimeters. This technology is associated with people since an interaction is needed to start the communication. Proximity technology is standardized in the ISO 14443. Finally, NFC extends the proximity technology by adding new functionalities, such as establishing a two-way communication between two NFC devices and allowing a device to emulate a contactless smart card. This technology is standardized in the ISO 18092 and ISO 21481. The NFC Forum was established in 2004 to promote the future use and development of NFC technology by standardization and device certification. Its goal is to achieve full interoperability between NFC-enabled devices. Being compatible with the already existing contactless cards and infrastructure, our NFC device can be used as a traditional card for typical applications such as electronic government, physical access to buildings, or payments. Furthermore, NFC makes new interactions possible, opening a new range of business opportunities that go far beyond typical smart card applications. From the simple exchange of business cards to sophisticated personalized transactions, loyalty programs, and even devices that can commission and configure themselves. NFC opens up a whole world of possibilities, also in the industrial, consumer, and IoT applications. NFC supports 3 different modes of operation. In read-write mode, our NFC device behaves as a contactless reader, and it can read or write tags and labels used, for example, in smart posters or to authenticate products. In the peer-to-peer mode, 2 NFC-enabled devices can exchange small amounts of data just by bringing them into close proximity. With peer-to-peer mode, you can exchange any kind of information, for example, a virtual business card or a picture. Using the card emulation mode, our NFC device can emulate a contactless card. In fact, we can emulate several, as we have lots of memory resources. The traditional contactless reader is able to read the emulated card in the same way as a plastic card. There are 2 communication schemes defined in NFC. In the passive communication scheme, the initiator generates an RF field oscillating at 13.56 MHz. The initiator sends commands to the target modulating the amplitude of its RF field. This way, it generates different pulse shapes that can be interpreted by the target. The target has no external power, so it uses the RF field of the initiator to transmit data. It uses the load modulation technique, where the target switches on and off an internal load that modifies the current consumption, generating a change in the RF field that can be detected by the initiator. In the active communication scheme, the initiator starts the communication by generating its own RF field. To send data, it modulates the amplitude of the field exactly in the same way as in the passive scheme. Once its commands are sent, it switches off its RF field and waits for the response of a valid target device, which must also be generating its own RF field. Visit our NFC knowledge base to read more about NFC technology at nxp.com.